In this video, we're going to look at solving a new type of equation. Alright, so before attempting this, make sure you're comfortable with roots and just the general strategy we've already talked about for solving equations, solving linear equations, and solving quadratics. Alright, so we previously learned about how to solve an equation like this, x squared equals 4. We take the square root of both sides, and the important thing is we get this plus or minus 2 for our final answer. And the reason we do this is because squares and square roots are opposites, so x equals plus or minus 2. But how do we solve an equation that has a square root? Well, we want to get rid of the square root, and we just said squares and square roots are opposites. So we're going to square both sides. The square of a square root cancels out, and I get 16. All right, so using squaring things to our advantage, all right, is going to help cancel out a square root. But here's the general strategy for solving a square root equation. I have to isolate the square root by itself on one side. So if it was like square root minus 4 in my previous example, I wouldn't square it yet. I want to get the square root by itself first before I square things. All right, then once they're by themselves, you square. I simplify, so square roots cancel out. 4 squared is 16. And now you're going to get this new equation. In this case, we're already done. We get this new equation, all right, that we have to solve, maybe using some of our other techniques. And one important thing, square roots have some rules about what you can plug into a square root and what you get out and stuff. So we have to check our final answers whenever we're doing a square root problem. We really haven't had to do this yet. We'll have to do this more in the spring, but we do have to check our answers that we get at the end. All right, so let's solve this equation. So square root of x equals 4. We just did this one. Square both sides. X equals 16. Right. And if we check our answer, we plug 16 in, and we get the square root of 16 equals 4, and 4 equals 4. All right, so this is an answer because it works out. Right. Next problem, I square both sides because the square root's already by itself. I get x equals positive 16. All right, negative 4 times negative 4 is positive 16. When I plug this into the equation, I get the square root of 16 equals negative 4. That's 4 on the left and negative 4 on the right, and that is not true. So this actually is not an answer. All right, and this is a common reason why we have to check our answers when we're doing with square roots. All right, square roots cannot equal a negative number because they're always going to be a positive answer out. All right, so sometimes it looks like you get an answer, but you actually didn't. All right, everything you did is right. It's just the process of solving it sometimes creates these answers that aren't actually true. All right, so these are called extraneous roots. All right, extra is the root. All right, there's extra solutions that you get. Again, you didn't do anything wrong. It's just the process of squaring an equation sometimes creates these extra answers that aren't actually true for the original problem. All right, so it's just whenever you're working with square roots, you got to check for extraneous solutions. All right, so let's look at a slightly more involved example. Again, the first thing you always have to do if you want to get rid of a square root is get the square root by itself. So right now on this side we have this minus 3, so we're going to add 3 to both sides. And now that I have the square root by itself, now I can square both sides. And when I square a square root, it cancels out, so I get 2x minus 7. It just cancels out that square root. On the right, I have 49. I'm going to add 7, and then divide by 2. That's 25 plus 3, 28. And again, whenever I'm solving this, I'm not 100% sure if this is the answer yet, so let's try to plug in 28. If I plug in 28, I get 2 times 28 minus 7 minus 3. 28 times 2 is 56. That's 49. Square root of 49 is 7. And I do get 4, which is what I want on that side. So this is the solution, and now I'm done. This one, similar. I want to get this square root by itself first, and right now there's this extra plus 2x. I'm going to subtract 2x from both sides. So I get 6 minus x equals my square root of 2x plus 12. But now my square root is by itself, so now I can square both sides. The right-hand side is a simpler one because whenever you square a square root, it just goes away. The left-hand side, I have to be a bit careful. Just remember, if you're squaring something, you're multiplying it by itself. So I have to FOIL this out. So if I FOIL this out, I'm going to get 36 minus 6x minus 6x plus x squared. now I have this new equation doesn't have square roots in it. So that's my first goal. I got an equation that doesn't have square roots. And now I have to figure out how to solve this new equation. So right here, I'd kind of take a little breather and say, okay, now I got rid of the square roots, and now I have a new equation I'm trying to solve. All right, so now we have to go back to knowing all of our types of ways to solve equations. And right away, I see this x squared. I know it's a quadratic. So the first thing I'm going to do is get 0 on one side. So I'm going to subtract 2x from both sides and subtract 12 from both sides, because I want to get 0 on one side. And then I'm also going to write my quadratic just in the descending way. So x squared, I have minus 6x minus 2x is minus 14x. 36 minus 12 is 24. Now a quadratic I could solve with the quadratic formula. I can also factor. For factor this one, I want numbers that add to negative 14 and multiply to 24. That's going to be negative 12. And negative 2. And because there was a 1 in front of the x squared, I can do the shortcut method of going straight to the factored form once I have those numbers. And now if x minus 12 equals 0, I get 12. If x minus 2 equals 0, I get 2. And this is the one extra thing. Again, remember when you're solving a square root problem, I have to check these answers. So the first thing I do is check 12. So 6 plus 3 times 12 is 6 plus 36 is 42. As that's the left-hand side, the right-hand side is going to be the square root of 2 times 12 plus 12 plus 2 times 12 is 36 plus 24 is 6 plus 24 is 30. So it doesn't look like 12 is actually going to work. Next, I do it with 2. 6 plus 3 times 2 is going to be 12. The square root of 2 times 2 plus 12 plus 2 times 2 is the square root of 16 plus 4. It's 4 plus 4, which is 8, and that also doesn't look like it works. So it's possible this has no solution. I'm going to look at the graph real quick and just see, because I feel like one of these should work, so maybe I made a mistake. And I just realized what my mistake is after looking at the graph and analyzing it, so it's good to kind of learn from mistakes. All right, you might have noticed a mistake a long time ago, all right, but maybe you were following along. Where's my mistake? My mistake is right there. I subtracted 2x from both sides. This should be positive 2x, or sorry, plus x. And so it's just quickly, all right, all of this is wrong. From there, so let's do the right thing. All right, this is going to be 36 plus 6x plus 6x plus x squared equals 2x plus 12. Subtract the stuff to the other side. It's going to be x squared. 12x minus 2 is plus 10x. Subtract 12 plus 24. And now I'm going to do x plus 4 times x plus 6 equals 0. That gives me x equals negative 4 and x equals negative 6. All right, so that's all the same stuff. Plug in negative 6, you realize that doesn't work. Plug in negative 4, you realize that does work. All right, so I did it all, the explanation with the wrong problem. All right, but if you do the right problem, you get negative 4 as your final answer. Okay, here's another one. Again, you can try it on your own. All right, but again, the first thing you should do, get the square root by itself. Now I want to square both sides. The right-hand side to remember to FOIL, so I always like to write this to the side to remember all the FOIL stuff I have to do. So first, outer, inner, last. All right, and again, this is where you take a little breather, say, okay, good, I finally got rid of the square roots. The square roots are gone, but now I have a new equation I have to solve. So how do I solve this new equation? Again, just like the last problem, I recognize there's these x squareds, so I want to get 0 on one side, so I'm going to move this stuff to the other side. So we get 0 equals 9x squared minus 7x squared is 2x squared. 15x minus 15x is going to be 15x. plus 25. Okay, the quadratic formula is always an option. Completing the square is always an option. But can we factor this? So if we factor it, we want to add to 15 and multiply to 50. And 5 and 10 is going to work. So I can factor this. All right, so I'm just doing my factoring method, which by now you are a master of. And now I know that x is negative 5 over 2, or x is negative 5. And just to save a little bit of time in the video, let's just see what would happen if I plug these in. And if I plug in either one of these, I get neither one of these works, so this original problem has no solution. And so you did all this work, and it turns out your problem didn't have an answer in the first place. Okay. All right, so for this skill, again, it's just about practicing, kind of getting better at the skill of solving things with square roots. But you can see when you're solving a problem with square roots, once you get rid of the square root, you might have to solve a linear equation, you might have to solve a quadratic equation. So it really is just taking one step past what we've already done, right? Figuring out how to get rid of that square root, taking a breather. All right, now how do I solve this new equation? And we have this one extra wrinkle of sometimes the answer you get at the end actually isn't an answer to your problem. All right, so we have these extraneous roots that can happen, and just be aware of those when you're solving these square root problems.